You are looking at NASA's worst nightmare, landing a 15-story steel skyscraper on the jagged, uneven terrain of the lunar South Pole. It is a physics problem called the inverted pendulum. Put a 52-meter tall cylinder on a 9-meter wide base. At a tiny 3 to 5 degree slope, the center of mass crosses the tipping point. Gravity takes over. The whole thing comes crashing down. This is not some abstract theory. It is the terrifying reality of the Artemis program right now. And people are panicking. Look at the Apollo lunar module. It was a spider, 7 meters tall, 9 meters wide. It had a low, perfect center of gravity. It was built to stick the landing on unknown terrain. Now look at the human landing system. It is a pencil, a massive 100-ton steel pencil trying to balance on rocks. The critics look at this and say, Elon Musk has lost his mind. They look at the massive dry mass and the insane requirement of launching up to 15 consecutive refueling tankers just to get this beast to the moon. They say it is too risky, too complex, too fragile. But SpaceX is not backing down. They are sticking to the 52-meter design, and they are completely ignoring everyone telling them to build a smaller, safer lander. Everyone has the exact same suggestion, just shrink it. Build a mini Starship, drop the height to 20 or 30 meters, widen the stance with aggressive landing legs. It solves almost everything. A shorter lander drops the center of gravity drastically. It increases the tipping tolerance from a terrifying 3 degrees to a highly comfortable 12 degrees. It cuts the dry mass in half. That means you do not need 15 tanker flights in low Earth orbit. You might only need 6 or 7. The math works perfectly on paper. So why does Musk refuse to do it? Why force the massive standard Starship architecture into a lunar landing role that it was clearly never designed for? People throw around terms like sunk cost fallacy. They say SpaceX already spent billions building the tooling and the factories for the 9-meter diameter, 50-meter long upper stage, and they are simply too stubborn to adapt. They say SpaceX cares more about launching huge internet satellites into low Earth orbit than safely landing humans on the lunar surface. Some engineers even argue we should go back to the Apollo-era direct ascent architecture or wait for nuclear thermal propulsion to save us from the refueling bottleneck. But those arguments miss the actual engineering constraints. The truth behind the 52-meter obsession is a lot colder. It has nothing to do with stubbornness or ego. It is about brutal industrial survival. Let us dig into manufacturing uniformity. Shrinking a rocket sounds easy to the armchair expert. You just slice out a few rings of stainless steel, right? Wrong. Aerospace engineering does not work like Lego. When you alter the height and mass distribution of a launch vehicle, you completely change its aerodynamic profile. You change its acoustic resonance during the violent stress of max Q. You alter how the massive super heavy booster flies with it sitting on top. If SpaceX builds a bespoke mini Starship, they are not just building a new ship. They are creating an entirely new aerodynamic regime. They would need a separate wind tunnel validation program, separate flight control software algorithms, separate robotic tooling machines inside the Boca Chica star factory. SpaceX is not trying to build the perfect artisanal lunar lander. They are trying to build the ultimate ruthless assembly line. Henry Ford did not build 5 different chassis sizes for the Model T. He built one. That uniform architecture is the only proven way to drive the marginal cost of a launch down to zero. Boeing built custom, highly specialized vehicles for every single mission. Look where that got them. The Starliner capsule is a bespoke, expensive nightmare. SpaceX built a generic, mass-produced cargo truck. It looks awkward for specific, delicate tasks, but it is brutally cheap to manufacture. But you still have to land that awkward truck on the moon without killing the crew. If you cannot widen the base, you have to cheat physics. You pull the center of mass down, way down. The current HLS design does this by making the bottom section incredibly dense. The landing legs are not made of exotic, lightweight carbon fiber. They are solid, reinforced 300 series stainless steel. They are heavy on purpose. Then there is the cryogenic propellant management. Starship uses specialized header tanks. By keeping the dense, remaining liquid oxygen and methane as low as possible in the hull during landing, you drastically drop the center of gravity. It is the exact same principle as a weighted punching bag. You can tilt it, you can push it, but the dense base constantly fights to pull it back upright. It is a brute force approach to stability. But the engineering gets even more violent. If you fire a massive Raptor engine directly above the lunar surface, you trigger something called plume surface interaction. The exhaust velocity of a Raptor is so extreme it acts like a giant plasma drill. You dig a crater in milliseconds, the ship sinks unevenly, and it tips over anyway. To stop that, SpaceX moved the landing engines. They put high-thrust gaseous thrusters right in the middle of the towering hull. They fire outward and downward. It spreads the force across a massive radius. No deep crater, no tipping. It is a bizarre solution, but it physically works. And then we face the giant elephant in the room, the 15 refueling flights. Competitors point to this sequence and laugh. They say it is an impossible logistical nightmare. They pitch nuclear thermal propulsion instead. A nuclear reactor heats liquid hydrogen and shoots it out the back. It gives you an incredible specific impulse of 900 seconds. You could theoretically fly straight to the moon without stopping for gas. Or they pitch direct descent, a massive expendable third stage pushing a tiny capsule, just like the Apollo Saturn V. But those ideas miss the entire point of what SpaceX is actually doing. Nuclear engines are at least 2 decades away from safely flying human beings. The radiation shielding alone destroys your payload fraction. Direct descent limits your cargo to a few rocks and a flag. The 15 tanker flights are not a bottleneck. They are a deliberate feature. SpaceX is forcing itself to solve orbital refueling right now because you cannot go to Mars without it. You cannot build a permanent lunar base without it. If you master the orbital transfer of thousands of tons of cryogenic methane and oxygen, you unlock the entire solar system. It is incredibly hard. The super-chilled fuel boils off in the harsh sunlight. The docking sequence has to be flawless at orbital velocities. But once you build that orbital gas station, the rocket equation stops being a tyrant. The moon becomes a local suburb. The 52-meter Starship HLS is not the safest lander ever drawn on paper. It is not the most efficient lander, but it is the only lander that scales. The people demanding a mini Starship are thinking about the moon. SpaceX is thinking about the supply chain. You endure the pain of 15 tanker launches and the sheer terror of the inverted pendulum because that is exactly how you industrialize deep space. Apollo was a glorious camping trip. Artemis, if it survives these engineering hurdles, is the railroad. But there is a massive catch. Transferring thousands of tons of super-chilled liquid oxygen in the vacuum of space is a thermodynamic nightmare. The unfiltered sun blasts the steel tanks with intense heat. The fuel boils and vents away into the void. If the boil-off rate is too high, SpaceX will end up launching tankers just to replace the fuel that evaporated the day before. The entire supply chain collapses before it even starts. So, how do you stop liquid oxygen from boiling in direct sunlight when your ship does not have any heavy insulation? We will break down SpaceX's thermal control secrets in the next deep dive. Do you think SpaceX can master orbital refueling before the 2027 Artemis deadline, or will boil off force NASA to delay the mission again?